Hello everyone. The genetic disorder that I've been studying is congenital adrenal hyperplasia. So what exactly is CHH? It is a genetic disorder that affects the adrenal glands, which sit on top of the kidneys. Here I inserted a picture that depicts that really well. The adrenal glands play an important role in hormone production, specifically in CAH, that is cortisol and aldosterone. And in CAH, there's an important enzyme that is necessary for the production of these hormones. The molecular cause of CHH is an endocrine disorder, and that here is the endocrine system, and you can see how the kidneys are involved, the spleen or the pancreas, and reproductive areas as well, which will go into the characteristics of CAH, and also a lot of other hormones that are in your thyroid and important ones in your brain as well. So overall, this does affect the secretion of these important hormones. The enzyme that is affected is the 21-hydroxylase enzyme. It has the important role of the cortisol and aldosterone production from the adrenal glands. The cortisol is important for maintaining blood sugar levels, protecting the body from stress, and suppressing inflammation. And then aldosterone regulates the amount of salt retained by the kidneys, and this affects fluid levels in the body. So a deficiency in this will affect a lot of the characteristics that I will hear explained soon. With mutation in the 21-hydroxylase enzyme, it becomes inactive, and then there is a deficiency. Without sufficient hormone production, numerous body functions are lacked. The hormone builds up in the adrenal glands, and it's converted to androgens. This leads to abnormal sex development and salt loss, and a myriad of other conditions that are related to these issues. So here are the major characteristics. There are a ton, and it does vary depending on the type of CAH, as well as age and gender play a role. On the type, there are milder forms that do show up later, and those will have different symptoms. And regarding to gender, females are diagnosed at birth because abnormal genitalia are present. For males, they don't have abnormal genitalia, rather it is enlarged. If CAH goes undiagnosed, a lot of the symptoms regard to the problem of the salt loss. So there's diarrhea, dehydration, vomiting, weight loss. You have low blood pressure and also low sugar levels. There's a water electrolyte imbalance, possible failure to thrive, shock, heart problems, and potentially going into coma. The physical effects are early pubic hair, severe acne, infertility, and then the girls, they get the masculine features and the infrequent periods. Males get the enlarged genitalia and also early puberty. So a lot of this goes into affecting, especially in the milder form, affect later in life around puberty, teenager age. And then both genders will be tall as children. They, early puberty and early growth, but then they will be short as adults. So the responsible gene for CAH is on the short arm of the 6th chromosome, and the main mutations are large gene deletion and gene conversion. And this gene is the CYP21A2 gene. So in this image that I provided, it depicts what gene conversion could look like. Here, the CYP21A2 gene is converting with another gene, and therefore it gets mutated and a wild type is developed. Now, how is CAH inherited? It is an autosomal recessive disease. So for autosomal recessive diseases, the parents must be carriers. So, for example, that would be heterozygous, big A, little a, for both mom and dad. So that means that they are carriers. In this image that I provided, you can see that both the mother and the father are carriers, and the chance that they will have a child with CAH is a 25% chance, or 1 in 4. And the other possibilities include an unaffected child, which is 1 out of 4. There's a 50% chance that the child will be a carrier, which would be the same as the parents, heterozygous, big A, little a, and an affected child would have to be homozygous, recessive, which would be 2 little a's. And here is a pedigree example of what generational inheritance of CHH could look like. So in a recessive pattern, you will see that 2 or both parents could not present the disorder. They won't show any of the signs or symptoms, but they can have children that do have the disease. So in this case, Bob and Joy do not have it, but they must be carriers, which is depicted by the heterozygous big A, little a. And then, for example, here we have Cindy and Lauren that did inherit the disease, and they are little a, little a. And then, obviously, then they can pass that down to their children, and the only way that the child gets it is if both parents are carriers. So, for example, on the far left, Rachel and Riley, it is impossible for them to produce a child that is affected with CHH because Rachel is big A homozygous dominant, so they cannot produce a affected child. So the prevalence and prognosis of CAH, it's very fortunate they can live a normal life. There's a lot of medications out there that have helped people with CHH, although there is no cure. There's a prevalence of 1 out of 10,000, and there is quite a big range for that, but with the most common form, 1 in 15,000 newborns are born with CHH. And it is more prevalent in certain populations, including Jews, Mediterraneans, Hispanics, and Yup'ik Eskimos. And there are a couple genetic testing options. So if there's known CHH in the family, you can do prenatal testing, and in that first trimester, it'd be cryonic villus sampling. Second trimester is measuring hormones in the amniotic fluid and through amniocentesis. And then required by every state, now they have the newborn screening blood test that does test for rare genetic disorders, and CHH is one of those. So even if it isn't known in the family, the newborn will still get tested for it. And then for the later CHH, there are blood tests, serum ones, electrolyte, aldosterone, cortisol, the hormone test. And then there can also be bone age studies, which is a picture of the left hand, and that can show if the child is aging quicker than a normal child of that age. And then genetic tests can be done to confirm the disorder in a child, but is not necessary. And here are my references. Thank you.